Yeah, I'm going to speak today about web frameworks and how we can make your life easier without doing too much work, because we all like to work on features, of course. So let's start with a thing, and this might be controversial, so don't laugh at me, don't yell at me, but React, Vue, Angular, Svelte, and Ember, really all UI frameworks have really taken over the world the last 6 years. And they've gotten increasingly popular over these few years, to the point where everyone's using them, or almost everyone. And this is further confirmed by various metrics. So let's have a look at some of these. So the first is the MDN Developer and Designer Survey. So MDN did a first release of their internals. Well, they did a survey of like you as a web developer. And they basically got 28,000 responses, and 72% of the respondents said they use one of these web frameworks, or UI frameworks, I mean. Furthermore, if you look at HTTP Archive, we found that 350,000 React sites are out there in the wild. But really what I'm going to speak to you about today is that building applications is hard. So choosing a UI library is certainly not enough to get started. You have to set up all these other build tools and other libraries to make sure that your app is successful. There's a lot of pitfalls to consider here. For example, some things could make your app slow without you knowing about it. And you need to ensure that your project can actually scale to the teams that you have. So you're at a massive company, you actually need to make sure that all your teams can work in a consistent and fast way while still being productive. And you don't want to complete framework rewrite every other month, right? And you also want to focus on building features and not so much on build tooling. So, okay, maybe you'd like to configure build tools and set up Webpack and Babel, etc. But your manager is probably going to hate you because you take twice as long. So yeah, but in reality, it's gotten easier over the last 2 or 3 years, because a new type of tooling has risen to popularity. And these are frameworks that are built on top of these popular UI libraries like React, Vue, and Svelte, for example. And this type of tooling focuses on user experience and developer experience. So the main goal is to find the sweet spot between providing the best user experience to users while making your team more productive in creating features and deploying them to production, for example. And this means combining great UX with great DX. So what is a web framework? So the Chrome team defines this as a type of library that's an opinionated system with default tooling that actually configures a lot of things for you and makes opinionated decisions that are good for your app. So it's an end-to-end system that controls every aspect from getting started to everyday development to deployment, for example. And it's positioned directly to impact both UX and DX by controlling the server and the client environment. And then also the build environment and the development and production environment. So it enables developers to successfully build and maintain high-quality production web apps. So web frameworks are positioned to inform performance. So in addition to developer productivity, so developer experience, we can also make opinions about how good UX looks like and how to make things fast for you. So it has opinions about server-side rendering, for example, and flushing early HTML chunks, or streaming rendering even. And it controls how the JavaScript, CSS, data, and images are served. So those can be optimized. And it unlocks those enhancements unlock new features like progressive delivery and lazy fetching. So really, there's a spectrum here. And it's not black and white per se. So on the one hand, there's UI libraries and frameworks that you all use today. And then on top of that, you have to build some kind of tooling. So a lot of tools have risen to popularity here. And Angular and Ember blur the lines a little bit, because does actually do a lot of optimizations for you for the web also. But for example, React, there's Next, which I work on. For Vue, there's Nuxt. For Svelte, there's Zapper. And a bunch of other tools that have risen to popularity recently. So it helps with a fuller web frameworks ecosystem. And if you're starting to build an app, it's very good to consider one of these frameworks as your starting point. I don't care if you use React, if you use Vue, just use one of these frameworks because they can optimize a lot for you without you even knowing about it. So there's another statistic to show this popularity growth, which is the Next.js downloads count. So in 2017, it was released in 2016, but at the end of the year, so the metrics are like 50K downloads or something like that, so it's not really interesting. So in 2017, there were 1 million downloads. In 2018, there were 4 million downloads. And in 2019, there were 11 million downloads. So you can see the growth over time that is pretty tremendous. Furthermore, I realized that Thank You Next, this song from Ariana Grande, was released exactly at this point, and you can see the curve go up. So it might affect the stats. I'm just throwing it out there so that you have all the pointers. So why would you use a web framework? Well, it's basically, it has decisions on a lot of stuff. It's not just scaling your application size or for an amount of users, but also for scaling your team and making them work in a consistent way. So when rolling your own solution, you have to keep in mind many different parts that have to play together that you might not know about. So for example, that goes from like the UI component model to routing to data flow and a lot of other things. So today I'm going to talk about a bit about how we build web frameworks. And I'm going to highlight just a few of those, because I only have 18 minutes, of course. And we're going to do that based on, let's see, we're going to do that based on real-world examples from React plus Next, the thing I work on. So they're applicable in pretty much every app that uses Webpack or Babel or anything of that sort. So let's start with the UI component model. So in case of Next, we use React, of course, and React handles the component lifecycle, your states, how things are rendered. And I won't go into this deeply because you all know about these UI frameworks. I hope so, at least. And choosing one of them is great. If you choose, it doesn't matter which choice you make. It's all really good and really well thought of. So then there is a UI component model also needs like some kind of CSS encapsulation, because otherwise you end up writing really large style sheets that conflict with each other or do similar things. So you need some kind of encapsulation. So in Next we built a thing called style.jsx that encapsulates all CSS based on this special JSX tag. It's actually very similar to Vue. It was inspired by the Vue single file component. So Vue has this thing called style scoped, which does a similar thing. So let's move on to routing. So routing in web applications is very complex because, like, for example, as your component generally has, so basically your app has many views in general. You don't just build one view, you actually build like multiple, even if you're building a dashboard, for example. So this could be like marketing pages, your blog, your dashboard, etc. And routing influences more than you might think. For example, like how is your code base structured so that you can define routes and where are routes actually defined, right? Because this is a component, or how do you link to that route? Or what if you want to do single-page application style client-side routing? And routing affects bundling. So if you choose to route in a certain way, you might have to bundle your whole application to the client side, and you don't want that in general. And routing influences the end user experience, because when a user clicks on a link, they expect it to be really fast. So let's have a look at the code base. So in Next, we standardized around this pages concept, which is you basically create a pages directory, and anything you put in there is a page that maps to a route. So, for example, you go from pages about.js to /about. But also dynamic routing is also supported. So it makes things simpler to reason about, because you can actually go into a directory and see all the routes that you have in your application. And then also, if you're debugging, for example, and you're on a certain route, you can actually just map on the file system what that route would be matched to, for example. And Next and Zapper were both inspired by this file system routing, so it's not just Next that supports this. And this also informs bundling. So, for example, every page is bundled as a separate JavaScript file. This avoids the pitfall of sending your whole application as one bundle, including all the routes that are possibly there, to the user that might want to just view the About page, for example. And teams can work independently on pages without hurting each other's performance. For example, if you import a large library in the blog page, it will only be affecting the blog page and not just not the About page, for example. So everything stays fast in the rest of the application. And then linking between pages. So in general, you want to do some kind of client-side routing nowadays. And to do client-side routing, you basically need some kind of link that is enhanced in a certain way that allows you to prefetch routes that will be upcoming, that will be clicked later on, basically. So in Next, we have this prefetching attribute that is enabled by default based on the viewport. So it prefetches all the links that are there, that are in the viewport, so that they're all fast when users click on them. But it's automatically disabled in slow network environments like 2G connections and that kind of thing. Furthermore, you can do smart prefetching using guest.js, which is a library to do basically you throw in your analytics data, and then the prefetching library will just figure out what to prefetch, which are the pages that are very popular, for example. And then let's walk through how this works. So first you click on a link. Very simple. Then we fetch the bundle. Then the JavaScript is executed, and then things are rendered. And this is just a general client-side routing, but the difference here with Next is that, unlike most solutions, we actually don't know what route exists. We only know when you click a link that you're going towards this URL, and we know how to fetch that URL. So let's move on to pre-rendering. And pre-rendering is a super complicated topic, but I'll walk you through it real quick. So it generally helps with SEO, meta tags, that kind of thing. Like if you want your pages to be indexed pretty fast by Google, for example, even though it supports JavaScript, other crawlers might not. And on top of that, say you have Twitter cards or something like that, they all need to be pre-rendered because Twitter can't render your JavaScript app, basically. It also helps with displaying your content fast. And I have a GIF that will show you why that is. So I hope that's playing. Oh, it is. OK. So as you can see, on the one hand, there is a React app that has pre-rendering. And on the other end, there is a React app without pre-rendering. So the case for without pre-rendering, you have to basically load all the JavaScript and all the data and all the CSS before being able to render, versus the pre-rendered one sends HTML and CSS at the request time, and then it renders faster, basically. So there's also a bunch of differences between pre-rendering. So there's two sections of pre-rendering. There's server-side rendering and static site generation. So server-side rendering means you render on demand every time a request comes in. It's dynamic, so any data that's there is always dynamic and will be sent to the user. But it requires runtime execution. So the downside there is that you have to host a Node.js server or something like that in order to make it work. Then static site generation works at build time. So you run it in your CI system. It's static, so it's always served from a CDN, for example, and it's always fast. So the way that pre-rendering HTML works is you do data fetching, because you have to do that before rendering. Then you render your page. Then you this framework would inject scripts and styles and preload tags and everything for you. And then HTML is output. And then there's hydration afterwards. And hydration, in case you've never heard of it, is basically booting up a UI framework after server-side rendering. So what this means is you basically send HTML to the browser, the page loads the JavaScript, and then hydration happens, which is a special method in React, for example, but also in Vue. And then the page becomes interactive, like your on-click handlers are added, React use effect is called, and that kind of thing. So data fetching is another thing to keep in mind, because you need to avoid waterfalls. And what do waterfalls mean? It basically means that you do one fetch, and then that causes another fetch, that causes another fetch, that causes another fetch. And in case of UI, when you're building UIs, it can actually cause multiple spinners in one application, in one page load, basically. So generally, this method tries to steer, like we introduced this method for data fetching inside of Next that steers users towards not chaining requests and making like the browser only request one URL. And some common ways that people do data fetching today is basically through fetch or GraphQL. So there are basically two oh wait, did I go back or did I go forward? Oh no, this is basically it ties into your rendering too. So basically you have two ways of rendering: get server props and get static props. And between choosing those, you can choose which would apply to your use case. And then it works at the page level, so you basically export a function. And the way that works on the client side is we just fetch another JSON file on top of that. So let's move on to compilation and bundling, and this will probably be the most interesting part. So you don't want to configure Webpack and Babel in general. You might have it internally for internal apps, but web frameworks have good defaults and help you there. So compilation and bundling in Next works by having pages compiled through Webpack. So we send it to Webpack. Then Webpack has a special Babel loader that uses Next/Babel, which is a special preset. And then we do minification and chunking optimizations. And there's a specific amount of chunking optimizations that we do, which output a library chunk, a frameworks chunk, and shared modules. Like say you import only in 2 pages of your whole app the same library, it will actually create a shared JavaScript chunk. And then we also output multiple targets. So this is where it gets complicated, because that whole graph might seem simple, but we have to do it 3 times with 3 different settings, with 3 different configs, really. One for modern browsers, one for legacy browsers, and one for Node.js. So the way that this works is for modern browsers that support async await and arrow functions and classes and like object rest spread and that kind of thing, they actually have a script type module that only loads in newer browsers. And then there's a script type, there's a script property called noModule that will only load in legacy browsers. And Next will handle this for you automatically, and other frameworks are also doing that. So we do a bunch of specific React optimizations. I wanted to call them out, because if you're building your own thing, it really helps. So one is that we automatically add import React from React. When you use JSX, we add development as an option. You should definitely do that. Most people don't. And we add targets to Babel preset ends to make sure that the right things are added, basically. And then we also automatically remove prop types, for example, in React. So we did this thing basically as an optimization of modern code, which is that currently there's preset env, but that outputs like quite large amounts of code. So we made an optimization called preset modules that will basically show you, will basically output smaller JavaScript automatically, and you should, and it's definitely compatible with all script type module browsers, for example. So you can look it up in github.com/babel/preset modules. And there's specific Webpack optimizations, but I'll skip them because I only have like 10 seconds left, and I'll walk you through it. But we did some like memory improvements inside of Webpack, and I'm going to skip really fast through them because I ran out of time, but it's all fine. So basically, we noticed in Webpack that it outputs modules all at the same time, and that causes massive memory usage. So we did this pull request to make it use less memory, but we weren't done there because it was still running out of memory for us. So we did this optimization inside of Webpack called output.futureEmit_assets. You can add it to your Webpack config, and it reduces your memory usage tremendously. So you definitely should add it. It's going to be default in Webpack 5, but you can already use it, and it's used in Next and Angular. So the takeaways of this talk are use web frameworks. They have good defaults. They have thought of everything that you could imagine. And if they haven't, make issues that would help with your use case. Routing at prefetching, because it helps with the way that users perceive performance. Avoid waterfalls on data fetching. And check out preset modules and definitely add future emit assets to your Webpack config. Thank you very much.